Welcome to this educational video on mathematical equipment used in physics for Class 11 students. In this video, we'll explore two powerful mathematical tools, differentiation and integration, which are fundamental for solving physics problems. Let's start by understanding differentiation. Differentiation helps us understand how quantities change with respect to other quantities, essentially finding the rate of change. In physics, we often need to calculate rates like velocity, acceleration, and many other physical quantities that involve change. Differentiation has various notations. If we call our function f of x, then f prime of x, written as f prime x, represents the derivative. We can also write it as dy over dx if y equals f of x, or as d over dx of f of x. All these notations represent the same concept, the rate at which f of x changes with respect to x. Let's look at a physics example. Suppose an object's position is given by the function s of t equals 2t squared plus 3t, where s is in meters and t is in seconds. To find the velocity, we differentiate the position function with respect to time. The velocity v of t equals ds over dt equals 4t plus 3 meters per second. And if we want acceleration, we differentiate the velocity function to get of t equals dv over dt equals 4 meters per second squared. Another important physics application is motion under gravity. When an object falls under gravity, its position is given by s of t equals initial position plus initial velocity times t minus 1/2 gt squared, where g is acceleration due to gravity. Differentiating once gives velocity v of t equals initial velocity minus g times t. Differentiating again gives acceleration of t equals negative g, which is constant, and equals 9.8 meters per second squared on Earth. Now, let's move on to integration. Integration can be thought of as the opposite of differentiation. It helps us find the total accumulation or sum of quantities. In physics, we use integration to calculate work, energy, center of mass, and many other physical quantities that involve accumulation. Integration also has various notations. If f of x is a function, the indefinite integral is written with this symbol, the integral of f of x dx, which equals capital F of x plus c, where capital F is the antiderivative of f and c is the constant of integration. For definite integrals between points a and b, we write the integral from a to b of f of x dx, which gives us the exact value of the accumulation over that interval. One of the most intuitive ways to understand integration is as finding the area under a curve. For example, the integral from a to b of f of x dx represents the area under the curve f of x between x equals a and x equals b. Let's visualize this with a simple function. Let's see an example of integration in physics. Work is defined as the integral of force dot displacement. For a constant force F acting along a straight line, the work done equals force times displacement, W equals F times S. But what if the force varies with position? Then we need to use integration. Work equals the integral from position A to position B of force as a function of position times ds. For example, in a spring following Hooke's law, F equals negative k times x, and the work done to stretch it from x equals 0 to x equals d is the integral from 0 to d of negative kx dx, which equals negative k times d squared over 2, or 1/2 kd squared. Another important application of integration in physics is finding impulse and momentum change. Impulse is defined as the integral of force with respect to time. The impulse equals the change in momentum, which is written as the integral from t1 to t2 of f dt equals change in momentum. For a constant force, this simplifies to F times delta T equals m times delta V. To summarize what we've learned today, differentiation helps us find rates of change like velocity and acceleration, while integration helps us find accumulations like work and impulse. These mathematical tools are essential for any physics student, especially in Class 11, as they allow us to analyze and understand how physical quantities change and accumulate. Remember, practice is key to mastering these tools. Thank you for watching.